In this mini lecture 10, we want to look at essentially mesh and nodal in terms of the least amount of effort. That is, if you get into a situation, and you will at some point in the course, where you are provided a circuit, again, many times, particularly in the earlier part of the course, even in the latter part, to make sure that you can do mesh and nodal, I'm going to essentially ask you to do nodal on the circuit, do mesh on the circuit. But in some cases, probably several cases, you are actually going to be able to decide. You get a circuit. I'm asking you for find the current through an element, voltage across an element. And then you have to decide, do I use mesh or do I use nodal? So generally speaking, I want to give you an intuitive feel for when you get a circuit, you are well armed in terms of saying, okay, what's going to require me more work or less work, essentially to do that. So how do we decide which of the two methods for a particular circuit implies the least amount of effort? I'm going to say right off the bat, you are expected to be proficient in both mesh and nodal. In fact, I'll make sure of that before you exit this course. That's a requirement. That's the name of the course is circuit analysis. We're looking at really those two methods as the main analysis method that we have for the course. Okay, so let's engage in a bit of discussion. Some of that discussion is a little dated, and you'll see why I'm saying that. Again, so I want to bring some points. None of the points I'm going to bring today should be disqualifying. And in some cases, they may, a point may be true. In some cases, it may be less true, even not so true at all. Okay, so keep in mind, these are things to consider. This is consideration when you're looking at a circuit in terms of how do you make a judgment call on which method to use, essentially. So no point is disqualifying here, just to give you a good feeling for how to make a good selection, good in terms of least amount of effort selection here. So when we look at nodal or mesh, we start by looking at the number of nodes in mesh. The number of nodes in nodal analysis. We essentially, the number of unknowns is the number of node minus one. If you have 4 nodes, 5 nodes, 4 unknowns, that basically tells you need to generate the 4 equations for the 4 unknowns you have. Similarly, in mesh, you're looking at the number of meshes. So a ballpark look at the circuit, if you look at the number of unknowns, and that is the number of node minus one in nodal, the number of meshes, you generally have a sense how many equations that you have to generate. Okay, less unknown, less equation, less effort. So that's kind of a first cut here. Of course, in nodal, again, assuming you're comfortable with dealing with voltage sources in nodal and with current sources in mesh, when you have voltage sources, particularly when you have independent voltage sources, the equations tend to be very, very simple. You write one equation. You don't have to do Ohm's law, substitute in. You basically write voltage 1 minus V3 equal the value of the source. On top of that, if you make a selection of the negative, one of the terminal of the independent voltage source as your reference node, you basically know the other node value because it will be equal to that value of that independent source. So that's a way to reduce the number of unknown. I think this particular consideration is of less importance in today's world because everybody has access to very, very advanced calculators. In fact, I'm expecting you do in this class so you can solve your linear system of equations. So it's less value, but nevertheless, if you can reduce the number of unknown by 1 by selecting your reference node, essentially at one of the terminals of the independent voltage source in nodal, you do that. A similar situation occurs in mesh if you have a current source on the perimeter, a current source that belongs to an independent current source that belongs to one mesh. You essentially know the mesh current. So that's very comparable to that, to nodal as well in that way. Okay, so in mesh, if the circuit has an independent current source in the branch that only belongs to one mesh on the perimeter of the circuit, you know the mesh current. So that then reduces the number of unknown by 1. At the very least, it's an easy equation to write. So lots of voltage sources, particularly lots of independent voltage sources, means that equations are easy to write. Equations like V1 minus V2 equal 5. So the more independent voltage sources you have, the easier the equations in Nodal. A similar situation, again, more current sources in mesh means that the equations are very simple to write. So let's take a particular circuit here and just to give us a feel for where we go here. If I first look at this circuit, I say this circuit has 3 meshes here, okay? There is a mesh here, there is a mesh here, and there is a mesh here. And then I look at the nodes, which I'm indicating here by the red dot here. I have 7 nodes. I have a whole bunch of nodes, 1, 2, 3, 4, 5, 6, 7 nodes. So on first look here, this looked like a winner for mesh. This looked like, why would I pick Nodal to do this? Okay, so just again, you have to look a little bit more in detail further down the discussion in order for you to reach that conclusion. Mesh may still be a good, but it may not be as good as you think, essentially. So if for example, I select this particular reference node here that I'm pointing here, I select that, that means I know V2, okay? So if I select that reference node here, that means I know V2. V2 is going to be equal to minus 24 volt, but I also know V1. V1 is going to be equal to minus 8 volt. So right off the bat, I go from 6 unknown, I go 6 unknown to 4. So the discussion between mesh and Nodal is looking a little bit fuzzier as opposed to 6 unknown and 3 unknown in mesh. 6 unknown in Nodal and 6 unknown and 3 unknown in mesh. So furthermore, I have equations that are very easily written for the dependent voltage source here. These source equations would be fairly easily written. It wouldn't require me to do a whole bunch of Ohm's law manipulation to do that. So things are, a little less clear than we thought. Probably mesh is the easiest one here, but it's not as decisive as I thought when I first looking at that circuit here. So if I do mesh, I would essentially put my 3 mesh currents, again, voltages on my resistors, and then write my KVL equations in mesh I1, I2, and I3. Okay, so this become fairly easy problems with a 3 mesh, and then I do Ohm's law, realizing that IB is equal to I3 in this particular case, and then substitute. And then we get our 3 equations, 3 unknown for our mesh, and then we solve for our mesh currents. So this gives you a feel for how to make judgment call. Again, with the aid of a calculator, like most of you should have, these considerations become less important than when we were dealing with having less powerful calculators. That would conclude that discussion for us.